guys, I just wanted to record a quick video to address a common error that was made on the lab this week. And it had to do with significant figures in calculations. So this is a question right off of the lab. If you have a sample of 3.5 times 10 to the 22nd atoms of tin, how many grams of tin do you have? So to solve this problem, we're going to go from, let's try that again. There we go. We're going to go from grams. No, we're not. We're going to go from atoms to moles to grams. Okay. And like any unit conversion problem we ever do, we're going to go ahead and start with the information that's given. So we're going to start with 3.5 times 10 to the 22nd atoms of tin. Then we're going to set up our train tracks here and let our units guide us. So atoms of tin is going to go on the bottom because that's what we're trying to get rid of. And then in the first step, moles of tin is going to go on the top. Now we just need to decide what equality is going to go into this conversion. And that equality is going to be that 1 mole equals 6.022 times 10 to the 23rd atoms. So here we're going to multiply across the top, divide by the bottom. So into my calculator, I'm going to type 3.5 times 10 to the 22nd divided by 6.022 times 10 to the 23rd. And my not so smart calculator spits out the following value. So not so smart, and the calculators don't consider significant figures. They just spit out numbers. So it's our job as the scientist to determine significant figures. This right here in the middle is a conversion factor. That conversion factor has unlimited or infinite sig figs. It's considered a counting number. So we do not consider that. So how do we determine sig figs? Well, we're going to go to the original measurement that was taken. So the original measurement, this 3.5, is 2 significant figures. So when I am considering the answer, considering taking this to the next step, the most that I can record is 2 sig figs. So 0.058. So the zeros being leading zeros, and the only 2 significant values are the 5 and the 8. And again, this is moles of tin. We're not quite finished with the problem, so we want to take that value and we want to start a new train track so that we can finish solving. So we've got that 0.058 moles of tin. Again, we're going to let our units guide us, so moles on the bottom. And in this case, we're going to go to grams of tin. So grams is going to be on the top. So again, we need to consider what conversion factor is going to go here. And this one's going to be the molar mass. So we're going to need to use our periodic table. So 1 mole of tin will contain 118.711 grams. That 118, again, came from my periodic table. All right, so we're going to multiply across the top, divide by the bottom. So 0.058 times 118.711. And again, my not so smart calculator spits out the following answer. So again, it is our job as the scientist to consider sig figs because our calculator doesn't. So again, we go to that original value. We're limited to 2 significant figures. So if I were to round this up, I could report 6.9, and that is grams of tin. So to summarize, we are going to look at the original measurement that was taken. That original measurement that was taken is going to determine the number of significant figures for our answer. So original value had 2 sig figs. Our answer is limited to 2 sig figs because this entire problem is multiplication division. I hope you guys found that helpful.